Hello, this is Mr. Huff, and I want to give you a crash course in Excel data analysis. This is going to be just a couple of examples to kind of get you started. So the first thing we're going to do is we're going to consider an experiment where we end up with some form of an equation that looks like this. We're going to say that that y is equal to n times x. Okay? That's what we're going to show in this graph. Okay, so what we're going to do is we're going to go ahead and make our constant n. N is always going to be 5, and I'm going to just put that somewhere in my table. Later I may want one that has q, and we're going to say q is 12. And then I'm going to go in here and set up my XY data table. You always put the independent variable first if you're going to use the traditional method of mapping in your data points. Think about what you were controlling and how something responded to that. Later, if you know what kind of thing you're trying to prove, you may inverse those, but usually you just put what you're controlling and then the responding variables. So I'm going to put x here and y there. And I'm going to put a series in. I'm going to have it count by 0.25s. So I go 0.25. And if I add 0.25 to that, I get 0.5. And if I add 0.25 to that, I get 0.75. So I've got a series that is kind of lined out. I highlight those three numbers. I click on this square at the bottom right, hold down left click and drag down. And now I've got several data points counting by 0.25. That's an easy way to use Excel to set up series. And now I'm going to put in a function that will multiply the value for n, which is a 5, times whatever is in the cell next to it. To do this, we have to use an absolute reference because 5 only occurs in one place. So we put equals and we click on the cell with the value in it that we want to multiply by. So n is 5, and it put in this value b1 right here. Okay. If we press F4 on your computers, you have to use the function key. So Fn, it's at the bottom left, and then the F4 key. So we put F4, and what that does is it puts $signs before the B and before the 1. And that means if you copy this formula around to other places on this table, it's always going to point at B and 1. Okay? It's called an absolute reference. Now we're going to multiply that with an asterisk times, we're going to multiply that times A6, which is 0.25 in this case. Okay, so it does the math for us, and now that value is 1.25. I would like to have this formula all the way down to the bottom here. If you double click right here, it will fill it in for you. Another way to do that is to just grab the little bottom corner and drag it down, and it copies that formula for you. Now we have an XY table. Again, if you were using, F equals M times A, and you have M and you have A, I would expect the calculation to be these letters to be F, M, or A based on whatever your experiment was. All right, let's make a graph. We're going to highlight this data table, and then we're going to click on Insert. And we're only going to use scatter plots pretty much in physics. We may use a bar graph every now and then, but usually it's going to be a scatter plot. We usually change one thing to see how something else responds to it. So I'm going to click the first choice here and the first choice there. And then we get this lovely graph that is not labeled very nicely, but we know what it means. And you can click on Format. And in here, there's some things about, somewhere in here it has, you'll have to hunt around. Design, there's a place where you can change the labels. I always have to hunt for it, but that's not what I'm after. So you can see we get a nice, perfect linear relationship. You can see that our dots are lined up in a nice straight row. But we would like to be able to describe that mathematically. So we're going to right-click on one of the data points, add a trend line, and we're pretty sure it's linear. So we're going to I'm going to go through a couple of things here. A couple of things I want to turn on. I need to think about this if I can include my intercept being 0. Always ask a question before you do that. You can't always do that, but right now I want to show you display equation on chart and the R² value on the chart. Okay. Once we turn those on, we should be able to see that we have a formula here that says y is equal to 5 times x. and R square value is exactly equal to 1. This is a perfect graph, and it's perfectly linear. So we'll talk more about R square in class, but basically it's a way of scoring how well that line fits on the data. And in this case it's perfect. If it's less than that, it's usually more like 0.9 something, and that's a pretty good fit. If you start getting below 0.9 and 0.8, your data doesn't fit really well, and you probably need to look at how you're doing your experiment. So you can see the formula that we started, y equals n times x, and here we see that y is equal to 5x, and that's our formula for the slope of this line. Let's look at some other things that might happen. Let's click on the trend line here, and you can see there's also exponential. It will try to calculate it, and you can see our R square value drop down, and we get this really bizarre looking equation here, and you can tell just by looking that doesn't fit very well. You could also look at logarithmic. It'll try to make it fit. Also, our R square value drops down to 0.87, and that line clearly doesn't fit very well. We'll try a polynomial. It'll try to solve that, and it can actually come up with a polynomial that fits that. That's very interesting. Let's try a power curve, and it says that it's exactly the same thing, but we know it's linear in this case, so choose the one that fits best. Let's look at another one. Here I've made another sheet that also has a data chart or data table on it. I want to make a graph, so we'll do it one more time. Insert, scatter plot, choose the first one, and now we have a very different looking graph. We have this nice curve here, so if you right click on one of these data points, choose add trend line, and it's going to try to make a linear fit, and that clearly doesn't fit. So let's go show how bad it is. We're going to display the equation on the chart, and we're going to display the R squared value. You can tell by looking at the data that the intercept is not part of this data set, so we would not choose intercept of 0. Okay, so let's try some other ones to see which one it is. So that's probably a power curve, and look at that. Our R square value jumps up to 1 with the power curve, and we can see that the formula it predicts is y equals 5x, and you can barely see it. Oh, I need to zoom in. We're going to zoom in on that. Okay, so now you can see the formula y equals 5x to the minus 2 power, and if you, I'm going to zoom back out, maybe if I can learn how to work a computer. There it is. The formula I use to develop these data points is y is equal to n divided by x squared. Okay, so we have 5, that's our n, and it's an inverse of the x squared, so that means we get the negative 2, so that's how that works. We'll talk more about these. I just wanted to show you a couple of ways to save some time using Excel. We're going to go through and make an example of all of these, and I'll probably make that a homework assignment. I know you're excited about that. All right, thanks.